Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Timeless Wanderings. Exploring the nature of time. Time, an enigmatic and omnipresent dimension, has intrigued philosophers, scientists, and artists throughout history. It governs our lives, dictating the rhythm of our existence from the ticking of a clock to the celestial movements of the cosmos. Yet, despite its pervasive influence, the nature of time remains one of the most profound mysteries. To explore what time is, we must delve into its philosophical foundations, its physical properties, and its impact on human experience. Philosophically, time has been a subject of debate since ancient times. Greek philosophers like Heraclitus and Parmenides offered contrasting views. Heraclitus famously declared that everything flows, suggesting that time is a constant stream of change. In contrast, Parmenides argued that change is an illusion, implying a static and timeless reality. These early philosophical inquiries set the stage for centuries of contemplation on the nature of time. Aristotle, in his work Physics, considered time as a measure of change with respect to before and after. He linked time to motion, positing that without change, there would be no time. This view influenced subsequent thinkers, including St. Augustine, who wrestled with the paradoxes of time in his Confessions. Augustine pondered how time could be both fleeting and eternal, existing as a present moment that continually becomes past. In the modern era, Immanuel Kant proposed that time, along with space, is a fundamental framework within which human experience unfolds. He argued that time is not an external entity but a part of the human mind structure, shaping how we perceive and understand the world. This idea profoundly impacted later philosophical and scientific explorations of time. The scientific understanding of time underwent a revolution with the advent of Einstein's theories of relativity in the early 20th century. Prior to Einstein, Newtonian physics held that time was absolute, a universal, unchanging backdrop against which events occurred. Newton's conception of time, rooted in the idea of an immutable clock that ticks uniformly throughout the universe, had dominated scientific thought for centuries. Einstein's theory of special relativity, however, introduced the concept that time is relative, not absolute. According to special relativity, time is intertwined with space to form a four-dimensional fabric known as space-time. This means that time can dilate, slow down or speed up, depending on the relative velocity of observers. For instance, an astronaut traveling at near light speed would experience time more slowly compared to someone on Earth. This phenomenon, known as time dilation, has been confirmed through experiments involving fast-moving particles and precise atomic clocks. Einstein's general theory of relativity further revolutionized our understanding of time by incorporating gravity into the picture. General relativity describes how massive objects, like planets and stars, warp the fabric of space-time, creating curvature that we perceive as gravity. This curvature affects the passage of time, a phenomenon known as gravitational time dilation. Clocks closer to massive objects, such as those on the surface of the Earth, tick more slowly than clocks farther away, like those in satellites orbiting the planet. This effect is not just theoretical. It has practical implications for technologies like the Global Positioning System, GPS, which must account for these relativistic differences to provide accurate location data. The discovery of time dilation and the malleability of time challenges our everyday intuitions. It suggests that time is not a fixed and uniform river flowing independently of everything else, but is instead influenced by the physical conditions of the universe. These insights have profound implications for cosmology, the study of the universe's origins, structure, and fate. Cosmologists study the evolution of the universe through the lens of time. The Big Bang Theory, the prevailing model of the universe's origin, posits that time, along with space and matter, began approximately 13.8 billion years ago in a singularity, an infinitely dense and hot point. As the universe expanded and cooled, time marched forward, allowing the formation of atoms, stars, galaxies, and ultimately, life. The arrow of time, a concept that describes the unidirectional flow of time from past to future, is a fundamental aspect of our experience. This forward progression is closely linked to the second law of thermodynamics, which states that entropy, a measure of disorder, tends to increase over time in a closed system. This increase in entropy gives time its apparent directionality, distinguishing the past, low entropy, from the future, high entropy. However, the laws of physics, particularly those governing fundamental interactions, are largely time-symmetric, meaning they do not inherently prefer a direction of time. This symmetry raises intriguing questions about why we experience time as moving forward. One possible explanation lies in the initial conditions of the universe. The Big Bang may have set a low entropy starting point, and the subsequent increase in entropy creates the time's arrow we observe. The concept of time also plays a crucial role in quantum mechanics, the branch of physics that describes the behavior of particles at the smallest scales. Quantum mechanics introduces the idea of superposition, where particles can exist in multiple states simultaneously until measured. This indeterminacy and the role of the observer in collapsing a particle's wave function add a layer of complexity to our understanding of time. In the realm of quantum mechanics, time is often treated differently than in general relativity. While relativity views time as a continuous dimension intertwined with space, quantum mechanics typically uses time as a parameter to describe the evolution of a system. This discrepancy poses significant challenges for physicists attempting to reconcile these two foundational theories into a unified framework. Efforts to unify general relativity and quantum mechanics have led to various theoretical approaches, such as string theory and loop quantum gravity. These theories seek to describe the fundamental nature of spacetime and may offer new insights into the nature of time itself. For example, some versions of string theory suggest the existence of additional dimensions beyond the familiar four, which could fundamentally alter our understanding of time. Beyond the realms of physics and cosmology, time profoundly impacts human experience and culture. It shapes our daily lives, structuring our routines and rhythms. Time is measured and marked through various means, from the movement of celestial bodies to the precision of atomic clocks. These measurements, in turn, influence our societal and technological advancements. Cultural perceptions of time vary widely across societies. In Western cultures, time is often viewed linearly, as a finite resource to be managed efficiently. This perspective emphasizes progress and future-oriented thinking. In contrast, many Eastern cultures perceive time cyclically, as a series of repeating cycles reflecting natural rhythms and seasonal changes. These differing views influence everything from work habits and social interactions to philosophical and spiritual beliefs. The subjective experience of time is another area of interest for psychologists and neuroscientists. Time perception can vary significantly depending on an individual's state of mind, activity, and context. For example, time seems to fly when we are engaged in enjoyable activities but drags when we are bored or waiting. This variability suggests that our brains construct our experience of time, influenced by attention, memory, and emotional states. Psychological studies have shown that our perception of time can be influenced by numerous factors, including age, culture, and the nature of the tasks we engage in. Children, for instance, often perceive time as passing more slowly than adults, possibly due to the novelty and intensity of their experiences. As we age, the repetitive nature of daily life may lead to a compression of time, where years seem to pass more quickly. Neuroscientists are exploring the brain mechanisms underlying time perception. Research suggests that different brain regions, including the basal ganglia and the prefrontal cortex, play roles in processing temporal information. These regions help us estimate durations, sequence events, and synchronize our actions with external rhythms. The interplay between memory and time perception is also crucial. Our sense of time is deeply connected to how we remember events. The more vivid and detailed our memories, the longer we perceive the duration of the event. Conversely, routine activities with fewer distinctive memories may seem to pass quickly. This phenomenon is known as the holiday paradox or vacation effect, where new and varied experiences create a richer tapestry of memories, making the time spent on vacation seem longer in retrospect. Time also permeates our creative and artistic expressions. Literature, music, and visual arts often explore themes of time, transience, and eternity. Writers like Marcel Proust and James Joyce have delved into the fluidity of time in human consciousness, capturing the complexities of memory and the passage of time in their narratives. Music, with its rhythm and tempo, provides a unique medium for experiencing time. Composers manipulate musical time to evoke emotions, create tension, and build narratives. Visual artists, too, have grappled with the representation of time. From the ancient sundials and astronomical charts to the modern art movements that play with the perception of time and space, the quest to capture the essence of time is evident. Salvador Dali's iconic painting, The Persistence of Memory, with its melting clocks, vividly portrays the surreal and subjective nature of time. The digital age has further transformed our relationship with time. Technologies like the internet and smartphones have created a world where information flows instantaneously, and the boundaries between past, present, and future blur. Social media and digital communication can create a sense of immediacy, where events are experienced in real time, but they can also contribute to a fragmented perception of time, with constant notifications and updates demanding our attention. Moreover, the acceleration of technological advancements and the pace of modern life have given rise to the phenomenon of time poverty, where individuals feel they have insufficient time to accomplish their goals and enjoy life. This sense of time scarcity can lead to stress and a decreased quality of life, prompting a reevaluation of how we prioritize and manage our time. In response to the pressures of modern life, movements such as slow living and mindfulness advocate for a more deliberate and present-focused approach to time. These philosophies emphasize the importance of savoring the moment, reducing stress, and fostering a deeper connection with oneself and the world. Our understanding of time is not only a journey through philosophy, science, and culture, but also an exploration of our place in the cosmos. Astronomically, time is woven into the very fabric of the universe. The celestial motions of planets, stars, and galaxies mark the passage of time on a grand scale, serving as cosmic clocks that have guided humanity for millennia. The rotation of the Earth on its axis defines the cycle of day and night, while its orbit around the Sun marks the passage of the year. These cycles are fundamental to our understanding of time, anchoring our existence in the rhythmic dance of celestial bodies. Ancient civilizations, from the Mayans to the Egyptians, built intricate calendars and monuments to track these astronomical cycles, reflecting the deep connection between time and the cosmos. Looking further into the universe, we see time expressed in the life cycles of stars. Stars are born from clouds of gas and dust, shine for billions of years, and eventually end their lives in spectacular supernovae or quiet fades into white dwarfs or black holes. These stellar life cycles are measured in cosmic timescales far beyond human comprehension, yet they are integral to the ongoing evolution of the universe. On an even grander scale, the expansion of the universe itself is a testament to the passage of cosmic time. The discovery that the universe is expanding, and that this expansion is accelerating, suggests that time is intimately linked to the very structure and fate of the cosmos. Observing distant galaxies, we look back in time, witnessing the universe as it was billions of years ago. The light from these galaxies has traveled vast distances to reach us, providing a window into the history of the universe. The ultimate fate of the universe, whether it will continue to expand indefinitely, collapse back into a singularity, or reach a stable equilibrium, remains one of the most profound questions in cosmology. Each of these scenarios paints a different picture of the future of time on a cosmic scale, raising questions about the nature of time itself and the ultimate destiny of all things. In contemplating the vastness of time from an astronomical perspective, we are reminded of our small yet significant place in the universe. The same forces that govern the movements of galaxies and the life cycles of stars also shape our everyday experiences of time. As we look to the stars and consider the grand sweep of cosmic history, we find a deeper appreciation for the fleeting moments that make up our lives. Time, in its myriad forms, connects us to the cosmos, linking the intimate details of our existence with the vast, unfolding story of the universe. The journey through time is a journey through the very essence of the cosmos, inviting us to ponder the mysteries of existence and the eternal dance of creation and change that defines our universe.